This is the video solutions for your homework on mixture problems. And we went through some of this work today. Let's go through these problems here. Notice that, let's do it this way. Mrs. Boyd has a desk full of quarters and nickels. So we have two types of quantities, or two types of items. We're going to say here that we're going to let Q here, this is our quarters. And we're going to let that be Q for quarters. So this is the number of quarters. The second type is nickels. So we're going to let N be our nickels. Maybe this be consistent. Let's use a capital N. And what they're saying here is that you have a desk full of quarters and nickels. And if she has a total of 25 coins here, so 25 here is quantity. So that first equation here is Q plus N is 25, where Q is the number of quarters and N is the number of nickels. It has a total value here. Now we have the amount, which is also known as our total value. So let's put this in red. This is the total, the amount. Total value here of $2.25. Now let's remember that the value of a quarter is 0.25. The value of a nickel is 0.5. And so if I actually take the number of quarters times 0.25 and the number of nickels times 0.05, it's going to have a total value of 2.25. Now this equation is 0.25Q plus 0.05N, and that's going to equal 2.25 for the $2.25. So the work we did in class today, if you remember, we have decimals for the second equation. And so for that second equation, what we're going to do here now is we're going to multiply the left and the right side by 100, which really means we're multiplying every term here by 100. That's going to move my decimal 2 spaces to the right for each number that has a decimal. So that the second equation really becomes 25Q plus 5N is 225. So here's my first equation. Here's my second equation. You're going to get to use again here your favorite method of solving a system of two equations and two unknowns. We're going to use substitution. Now remember here, I'm going to translate. I'm going to solve for Q. And what that means is I'm going to translate. I'm going to subtract N from both sides, really. Okay, and you're going to end up with your first equation being, let's do it. Let's put it here in blue. Q then will be (25 minus N). Okay, so we're going to, remember, subtract N from both sides here. That looks like a plus sign, okay? Or you can think of translation, move N to the other side and change its sign. We're going to substitute this Q into the second equation. In other words, this now is going to be really 25 minus N. So I get an equation here that reads like this. We have 25 times 25 minus N plus 5N is 225. Well, 25 times 25 is, what do you guys remember? 25 times 25 is going to be 600 and what? 25. So I get 625 minus 25N, because we are distributing, plus 5N will give us 225. 625 minus 20n, if I simplify this, is 225. I'm going to subtract 625 from both sides. So we get negative 20n is actually negative 400. Divide both sides by negative 20. And we get n here to be 20. There's 20 nickels. Now, if I know there's 20 nickels, let's go back here and erase some of this stuff here. Okay. If we have 20 nickels, we're going to plug in that 20 here in the first equation for the 20 nickels. And now I know that 25 minus 20 is going to be the number of quarters here. So I'm going to have 5 quarters because 25 minus 20 is actually 5. So I don't have a lot of space to do all this work. Believe it or not. And so this is actually how we answer the question. Notice that there's 5 quarters, 20 nickels for a total of 25 coins. And Q is the number of quarters, N is the number of nickels. We actually answered the question here. So this is number 1. Number 3, we have a sum of money amounting to, so that's an amount of $5.65. So this goes down here for the total, $5.65. Now we have dimes and quarters, so we're going to let D be the number of dimes and Q be the number of quarters. So we have 2 types of items, dimes and quarters. D is the quantity of dimes, Q is the quantity of quarters. And it says they are 28 coins, which means the total quantity of coins is 28. My first equation is D plus Q is 28. Now let's look at the amounts. The amount of a dime is actually going to be 0.10. That's the amount of a dime. The amount of a quarter is 0.25. So if I want to look at the total amount in quarters, I'm going to take that 0.15 and I'm going to multiply it to this D. I'm going to take the 0.25 and multiply it to Q. So that my second equation becomes 0.10D plus 0.25Q, and that will equal $5.65. Again, multiply every term by 100 or move the decimal 2 spaces to the right for each one of those, and you get 10D plus 25Q is 565. My second equation, my first equation. We can actually use here again the, let's see what kind of space we have. We got some space. We're going to have to solve this system here, and I'm going to say use substitution, meaning translate the Q. Move the Q on the other side, and you'll have D equals 28 minus Q. Remember, when you translate the term, you change the sign. So if Q is on the left and it's positive, it's now going to be on the right and negative. We can now substitute this D, which is 28 minus Q, into the second equation. We get 10 times 28 minus Q plus 25Q is 565. Distribute 280 minus 10Q plus 25Q is 565. 280 looks like plus 15Q is 565. Subtract your 280 from both sides. We get 15Q. 15Q will be 565 minus 280. So 565 minus my 280 is 285. Divide both sides by 15, and we get Q equals 285 divided by 15 is 19. We have 19 quarters. Using backstop, plug in 19 for Q so that the number of dimes then becomes 28 minus that 19, or we're going to have 9 dimes. Notice that if I have 19 quarters down here and I have 9 dimes, we do have 28 coin. And you're done. Number 6. A woman made a deposit for $339. That's a total amount. If her deposit consists of 99 bills, that's the quantity. She has 99 bills. Let's change that. Let's put that in blue. So she has 99 bills. Some of the bills are $1 and the rest are 5. So the first type is 1. The second type is 5. Now those are dollars. I'm going to use the capital letter O for the quantity of ones, and I'm going to use the capital letter F for the quantity of 5s. So my quantity equation is capital O plus F is 99. Now remember, the amount of $1 is 1, and the amount of 5 is 5. So that 1 times and 5 times the quantity of 1s and the quantity of 5s, this is a 1 times 0, that's not 10, plus 5F, should give me the total value of $339. Now 1 times anything is itself, so let's just actually leave it this way. These are my 2 equations and my 2 unknowns. We can solve this any way we like. So if you want, we can use the addition method or the elimination method. Let's eliminate the O. Now we can do that by multiplying every term in the first equation by -1. That changes the sign for every one of these terms. So when I add both sides by this addition method, I get 4F is, this is -99 plus 339. So the answer is going to be positive. So I need to know what 339 minus 99 actually is. We find that this is 240. Let's review. These are all opposites because we multiplied by -1 to the top equation, which is really multiplying -1 to every term. Every sign is now negative here. We're going to divide here by 4 for both sides, so we have cancellation. And now my F here is 240 divided by 4, which is 60. I have $65 bills. 60 goes here. Now, if I have $65 bills, let's go back. O plus F was 99 to begin with, right? This is my quantity equation up here. So I'm going to write down that equation, and I'm going to use the value for F to be 60 So I can now solve this equation. I have 0 or O plus 60 is 99. Subtract 60 from both sides. 99 minus 60 is 39. I have 39 ones and I have 65s, and we have actually solved this mixture question. This is number 6. Number 8. Now, one, 3, 5, 6, and 8, 10, 12. Okay, well, it looks like we're going to do some of these evens. That's how it turned out. No big deal. No big deal. So some of these problems are evens. Okay, I thought we'd do the odds, but all right, let's just go with this. It's not a big deal. You could do the odds. I'll do some of the evens. Now let's look what's happening here. Ron and Kathy are ticket sellers at their class play. Ron is handling student tickets that sell for $3 each. So Kathy is selling the adult tickets for $5.50 each. If the total income for 24 tickets is $99.50, how much did Ron sell? So Ron handles the $3 tickets. Kathy handles the $5.50 tickets. Okay, so we'll put Kathy up here. Kathy handles the $5.50 tickets. Okay. The total income for 24 tickets. Now that's a quantity. There's 24 tickets. So here's what we can do. We're going to let R be the amount of tickets that Ron sells. Let K be the amount of tickets that Kathy sells. So we know that Ron's tickets sell for $3. So the amount in terms of value, 3R plus 5.50K is going to give us the total value of $99.50. So let's look at it this way. R plus K is 24. 3R plus 550K is 99.50. Okay, let's write down the equations here. Okay, let's go back and review. We got Ron and Kathy. Type 1 is Ron, Kathy is type 2. So the number of tickets Ron sells, R, plus the number of tickets Kathy sells, K, better be 24. I get R plus K is 24. The amount here is $3 for the amount of the value of the tickets that Ron has versus $5.50 for Kathy for a total of $99.50. So 3R plus 550K gives us $99.50. Don't forget, move your decimal. 2 spaces, 2 spaces, even this one 2 spaces. So 3 with the decimal after it, moving it 3 spaces becomes 300R plus 550K, and that'll be $99.50. 2 equations, 2 unknowns. We're going to solve by the substitution method. So translate this K, and you get R is 24 minus K. Okay, substitute 24 here minus K. So this equation is now 300 times 24 minus k plus 550k will be 9950. Use a distributive property. 300 times 24 is 7200 minus 300k plus 550k is 9950. Simplify this. 7200 plus 250k is 9950. We're going to subtract the 7200 from both sides. We get 250k is 9950 minus 7200 gives you 2750. So we're now going to divide both sides here by 250. K is 2750 divided by 250, we find is going to be 11. So K is 11. Kathy sold 11 tickets. Back substitute. 24 now for the number of tickets Ron sold. 24 minus 11. 24 minus 11 gives us 13. So Kathy sold 11 tickets. Ron sold 13 tickets for a total of 24 tickets. All right. Number 10. We have some investment. Walt made $8,000 last year from a part-time job. He invested part of the money in 10%, the rest at 7%. If he made a total of $710 in interest, how much was invested at 7%? Alrighty. We have two types of accounts here. One that pays 10% and one that pays 7%. Think of the money as quantity in dollars here. So we don't know how much the quantity here that was invested in the 10% account, so we're going to call that X. We don't know what the quantity is in the second account that was invested, so we're going to call that Y. It's a different letter. What we know is that if we add these two values in terms of quantity, we'll have $8,000. So the sum here of the amount invested in account 1 plus the amount in account 2 represents $8,000. That's your quantity equation. Now the amount equation in this case is your interest. We don't have a lot of space here, so I'm going to try to write it this way. Interest. Okay. That's a little better. So what we know is that 10% of the amount invested in account 1 plus 7% of the amount invested in account 2. This is just my interest. I get interest in account 1, interest in account 2. When I add it together, I'm supposed to get $710 in total interest. He made a total of $710 in interest. So this is my interest equation. Now 10% is really 0.10. So I'll write this as 0.10 times X plus 0.07 times Y, better be 710. Now moving my decimal like I did before, because I have these decimals, 2 spaces to get nice whole numbers. These are blank, so put zeros. My second equation becomes 10x plus 7y equal to 71000, 71,000. Here's my second equation. Here's my first equation. We're going to substitute. translate the y, and you get x equal to 8,000 minus y. Substitute that into the second equation, and here's what we get. 10 times 8,000 minus y plus 7y is 71,000. Now 10 times 8,000, since we distribute, is 80,000 minus 10y plus 7y is 71,000. We're going to subtract 80,000 from both sides. We're going to actually simplify here too. So negative 10y plus 7y is going to be negative 3y, and then 71,000 minus 8,000 looks like it's going to be negative 9,000. So when I divide both sides here by negative 3, I end up with y equals 3,000. So we're going to end up investing $3,000 at 7%. That implies that we invested $5,000 at 10%, because if I plug in the 3,000 here for y, I get 5,000. Now this is the amount that's invested in both accounts. They only asked us for how much was invested in account number 2, or type 2, which is at 7%. And that's right here, $3,000. Number 12. Tim and Judy mix 2 kinds of feed for dogs. Now, the second sentence has all the information we need, believe it or not. I want to point out that the second sentence is going to have some information that's silent. And wherever you have a quantity that is silent, that's going to be what your variables are. And if it's silent in terms of quantity, we're going to call that a variable x, or we're going to call it y. And that's the key. So the first quantity that we looked at from class was to notice that in this question, they're talking pounds here. Pounds of dog food. So I'm going to notice here, this is in pounds. Okay, LBS, pounds. So if we read this, we say, they wish to make 21 pounds of feed. They wish to make 21 pounds. This statement here, when they say they want to make a total of 21 pounds, they didn't say total. But that's really what's implied, that the total here is actually 21 pounds of the feed they want to create. They're saying that they wish to make 21 pounds of feed. That's really the total. Now let's look at the details. Now the next part of this has a lot of information. They want to make this feed to be worth 60 cents per pound. So that total here is going to be worth ultimately 60 cents per pound. We can put it here as well. Just want to notate it in both places. You'll see why I do this. So they want the total to be 60 cents per pound. And what else did they say? Let's go back and point that point out. This total is supposed to be worth 60 cents per pound. Okay. Whew. Now let's look at this. How are they going to accomplish this? By mixing. You say, by mixing, what are they going to mix? One kind worth 68 cents per pound with another worth 64 cents per pound. Notice the silence. They did not indicate to you at all the quantity in pounds that they're going to mix. They just give you the rate of 48 cents per pound and another rate of 64 cents per pound. So here's what I want to propose to you. You're going to let the quantity here for the 48 cents. this 48 cents per pound quantity, I'll put it over here, okay? Right, this 48 cents per pound, that type. They didn't tell us the quantity, we're going to let that be X. Compare that to the 64 cents per pound. They didn't tell us the quantity, it was silent there too. We're going to let the quantity there be Y. So what you end up getting as an equation here for that quantity equation is X plus Y is 21 because you have X pounds of type 1 and Y pounds of type 2. It is silent, but they told you the total is 21, so there's your first equation. Now the amount question is actually the amount here, or the amount portion, let's say. This is the amount here in dollars. So the first equation is a quantity in pounds. The second one is an amount in dollars. Let's see what we mean by that. Now at 48 cents a pound, this is going to be the following. I'm going to take that 48 cents per pound times the number of pounds of type 1. We're going to add it with the 64 cents per pound times the number of pounds of type 2. We don't know what they are. We're calling them X and Y. And it's going to end up giving us this thing called, we want 21 pounds here of 60 cents. So that's the amount in dollars. Now 21 pounds at 60 cents per pound, we have to find what that is. That's 21 times 0.6. That's 12.60. So this number here is $12.60. This is the money equation. So I have here the 0.48x plus the 0.64y better be $12.60. The key to this problem is over here. This $12.60. You have to multiply the 21 pounds with 60 cents per pound because we're getting an amount equation here that's in dollars. This is what we discussed in class. Now, the second equation involves decimals, so we're going to have to multiply by 100 to move these decimals 2 spaces to the right. And you'll end up with, for this second equation, 48x plus 64y, and that will give you 1260. So I have this second equation and this first equation. What we're going to do now is we're going to use the substitution method, and we're going to find the quantities. Now, I'll say translate your y, and so you get x is really 21 minus y. Plug that in the second equation, and let's do some algebra. 48 times 21 minus y plus 64y is 1260. We need to know what 48 times 21 is. 48 times 21 gives us 1008 minus 48y plus 64y is 1260. Now 1008, now negative 48y plus 64y, let's think about that. That's 64 minus our 48. That gives us a positive 16y. And that will be 1260. Subtract both sides. Subtract 1008 to both sides. We end up getting 16y is, it looks like it's going to be 252. So we got 1260 minus 1008. That gives us 252. Okay. We're now going to divide both sides by 16. And we'll get y equal to 15.75 pounds. So if we go back here, we have to have 15.75 pounds of type 2. And what that implies then, if this is 15.75, we'll get x being 21 minus 15.75 gives us a negative 5.2, or a 5.25 pounds, sorry, 5.25 pounds. So 5.25 pounds for type 1. Let's go back. They want to know how many pounds of the cheaper kind should they use. A little tricky. What is cheaper, 48 cents per pound or 64 cents per pound? 48 cents per pound, and you're going to need 5.25 pounds. That's your answer here. So this is how we handle the mixture question for number 12. Number 14 is the same type. It's candy, though. Let's be careful. Alan wishes to mix candy worth $2.43 per pound. Now, that's what she wants to end up with. Remember, this is the dollar version. So I'm going to keep track of that as $2.43 per pound here. Now, Alan wishes to mix candy worth $2.43 per pound with candy. Sorry, we made a mistake. Let's go back. Got to be careful. Number 14, let's read this completely. It's a little tricky. Alan wishes to mix candy worth $2.43 per pound with candy worth $3.92 per pound to form 32 pounds of a mixture worth $2.99. All right, here we go. Alan wishes to mix candy. You don't know how much. She wants to mix candy worth $2.43 per pound with another type of candy that's worth $3.92 per pound to form 32 pounds. Let's put that in red. 32 pounds of a mixture worth $2.99 per pound. So we started this off by making a mistake. Let's read it and figure this out. So again, we have the dollar amount, and again we have the quantity in pounds, LBS. Now, type 1 is actually $2.43 per pound, so I'm going to label that as, I guess we'll put that in blue, $2.43 per pound for type 1, where the second type is actually $3.92 for the second type. And ultimately, they're going to make a mixture that's worth $2.99. So this is $2.99. It says right here in red. We'll emphasize that. Okay? The mixture, and this over here is where your mixture ultimately is going to be about. Now, what they gave us was they told us that they're going to want this mixture to be 32 pounds. Okay? Now their question is, how many pounds of the more expensive candy should she use? Well, they never mentioned anything about pounds for each type. Type 1 and type 2, they only gave us the dollar per pound. So we're going to let that first type be X. Quantity is X pounds. The second type, we're going to let be Y. The quantity is Y pounds. So that our equation is X plus Y is 32. Now, we know something about the dollar amount, meaning we know that $2.43 per pound times X pounds plus the $3.92 per pound times Y pounds, okay, better give us 32 pounds at $2.99. We don't know what that value is. We're going to have to find out what 32 times 2.99 is. So 32 times 2.99 is 95.68. So my second equation is 2.43x plus 3.92y will be 95.68. Okay, we're going to have to fix the second equation again by multiplying every term by 100 so that each decimal moves 2 spaces to the right. The second equation becomes 243x plus 392y, and that'll be 95.68. Now remember, translate, and you get x will be 32 minus y. We're going to solve this system, substitute for x, 32 minus y, and let's see what we get. 243 times 32 minus y plus 392y will be 95.68. We're going to have to get rid of the parentheses by distributing. So let's see what we get. 243 times 32. We get 776 minus 243y plus 392y gives us 95.68. Okay, so 776. 392y, we're going to have to find out what this is by combining like terms. 392 minus 243 gives us 149y. Now that's going to be 95.68. Subtract this 776 from both sides, and we'll get 149y will be 95.68 minus the 3 7s and a 6, and you'll have 1792. Divide both sides by 149 to solve for y. We get y equals 1792 divided by 149 gives us approximately 12. Approximately 12 pounds. So we found the value for y. Y is about 12 pounds here. So if I plug in 12 for y, we know x is 32 minus 12, or x will be now 20 pounds here. So number 14 here is x is 20 and y is 12. They ask the more expensive. Well, the more expensive here is 392. So it looks like the answer is going to be there 12 pounds. Number 16. Coffee. Coffee works the same way. And let's actually be careful with this one, and like we weren't so in the first one, or the prior one, number 14. Let's try to find out what's going on here with this. A merchant has coffee worth $20 a pound. She wishes to mix with coffee with she wishes to mix with 50 pounds of coffee worth $50 a pound to get a mixture that can be sold for $30 a pound. Okay. Let's use our colors here. Let's read this again. A merchant has coffee worth $20 a pound. So she has some coffee worth $20 a pound. Okay. She wants to mix it with 50 pounds of coffee worth $50 a pound. Let's change the color. She wishes to mix with 50 pounds of coffee worth $50 per pound. Now, she wants to obtain here a mixture. Over here. She wants to get a mixture that can be sold for $30 a pound. Now, I'm going to put this here for $30 a pound. Remember, this is my amount here, and over here I have my pounds, LBS. let's go back and let's read this again. A merchant has coffee worth $20 a pound. Now, this is the first type. She has a $20 a pound type. She wants to mix with 50 pounds of coffee worth $50 a pound type. So, this is the type that she has, and she wants to end up with a mixture that's $30 a pound. Okay. Let's go back. Let's think of the quantity in actual pounds. It's going to be silent in some cases, and it's going to be specific in others. If I read that statement, a merchant has coffee worth $20 a pound. She wishes to mix with 50 pounds of a second coffee. So the second coffee, we know specifically she has 50 pounds of that. She's silent with the first one. So let's go back here. I'll put that in green so that we're consistent. She's silent about the $20 a pound type. So we're going to call that X. And since we don't know X, we don't know what that value is. We know that X plus 50 will be some value here. We're going to call this other value Y. Okay? That's your total. You don't know what the total is. She just told you what the type 2 quantity is. That's 50 pounds. So that first equation here is X plus 50 is Y. That's your first equation. Let's look at the amount now in terms of money. Now what's supposed to happen is, let's remember, $20 per pound times X pounds is how much in the first type we have. And then I'm going to say to you that $50 per pound times 50. By the way, that number is 2,500 is what we have for type 2. And we want to end up with, again here, $30 a pound times Y. So that the second equation is going to be 20X plus that 2,500, and that's going to be 30Y. Okay? So the second amount, or the second equation, is an amount equation in dollars. The first is a quantity equation in pounds. We have two equations and two unknowns we can solve for by substitution. Now the substitution here is easy because it's already solved for Y. In other words, take a look. We already have X plus 50 is Y. We're going to plug in this Y here in the second equation. So we have X plus 50 here for my Y. 20X plus 2,500 will now become 30 times X plus 50. 20X plus 2,500 will now become 30X plus 1,500. We're going to solve this for X. I'm going to subtract 30X from both sides here. I'll end up with negative 10X plus 2,500 will be 1,500. I'm going to subtract 2,500. We end up with here negative 10X being negative 1,000. So you get to now divide both sides by negative 10 here. We end up with X being 100. So 100 pounds of type 1, if X is 100, that means Y is 150. Because I plug in 100 here for X, 100 plus 50 is 150. So they're going to ask us now in this question here, they're going to say what? How many pounds of the $20 coffee should be used? Well, that's right here. The $20 per pound coffee, we're going to use 100 pounds. That's how we do number 16. Number 18. Again, let's take a look at what they give us. This here, we got to be careful. This is a classic mixture question. We're mixing, I guess, cement, two types. If we read this, and we'll have to read it probably a few times, we're saying a contractor mixes concrete from bags of premix for small jobs. How many bags with 3% should be mixed with 12 bags of 15% to produce a mixture containing 11%? All right, there's going to be some silent information here, and there's going to be some solid information here. Let's stop and think about the quantity, though. This is in bags, not pounds anymore. This is in bags. So how do we know that? Because they tell us this is in bags. And this second amount is really in percent. It's not dollars. So the amount in this case is percent. The quantity is in bags. We have two types we're mixing for a total mixture type. Out here is the mixture. So let's read this again and keep this in mind, right? A contractor mixes concrete from bags of pre-mix for small jobs. How many bags with 3%? How many bags with 3% should he mix with 12 bags of 15%? So we have two types. We have 3% type, and notice, what's the question? How many bags with 3%? We don't know how many, it's silent. That's X. Should he mix with, what's this? 12 bags, wrong tool. He's going to mix with 12 bags of 15%. So the second type is 15%. Okay? And the quantity they did give us, that's 12. 12 bags of 15% cement to produce a mix. This is in red. Your mix or mixture containing 11%. So the mixture has to be 11%. Now we don't know what the total is, so we're going to call that Y. Our first equation is X plus 12 equals Y. These are the things we discussed in lecture. That's our first equation for our mixture question. The second equation is the following. We're going to look at the percent. So this is easy. Just take your 3% and multiply it to X. So 3% of X. Take your 15%, multiply it to 12. 15% of 12. And then take your 11% of Y. 11% of Y. Now don't forget what 3% is actually again. This 3% is 0.03. Okay? Don't forget the percent language, so let's write it down together. 3% is 0.03x. 15% is 0.15y. 11%, 1111. Oops, let's go back. That's not 0.15y. We forgot to compute 15% of 12. So we're going to compute 15% of 12. 0.15 times 0.12, we get 1.8. So this value is really 1.8. Let's emphasize this. We can compute that. 15% of 12, that's 1.8. So this is plus 1.8, and that will be 0.11y. Here we go, our two equations and two unknowns. We can solve this. Okay, now notice here, this is already of the form, or I should say, y is x plus 12. So I can plug in for my y, x plus 12. Here's my equation now. 0.03x plus 1.8 will be 0.11 x plus 12. Now I'm going to say multiply both sides by 100 so you can move this decimal 2 spaces. Every decimal gets moved 2 spaces. So I have the following. 3x plus 180 is 11 times x plus 12. Or 3x plus 180 is 11x plus 11 times 12. That's 132. We're going to solve this for x. So we're going to do some algebra. Subtract 11x from both sides. 3x minus 11x is negative 8x plus 180. That's going to be 132. Subtract 180 from both sides. Negative 8x will be 132 minus 180. Negative 48. Divide both sides by negative 8. You get x here is going to be 6. So there's going to be 6 bags of 3% cement. What's the question? How many bags of 3%? Yep. This is the answer. They want us to know how many bags of the 3%, and that's going to be 6. So 6 bags here for number 18. 20. Okay, another mixture question. Ann and Nancy use a metal alloy that is 17.8% copper to make jewelry. Okay. Well, they use a metal alloy that's 17.8% copper. How many ounces of 13% alloy must be mixed with 29% alloy to form 90 ounces of the desired alloy? All right. Let's go back. Notice what your quantity is. The quantity here is in ounces. The amount here, again, is in percent. So Ann and Nancy use a metal alloy that is 17.8%. Let's think about this. The next phrase is, how many ounces of 13%? Well, that's one type. How many ounces? We don't know. We're calling that X. Must be mixed with a 29% alloy. Well, that's a different alloy, so we'll color that in blue, I guess. That's a 29% alloy. Okay. How many ounces of 13% must be mixed with 29%? And notice again, it's silent on the type 2. We're going to call that Y. To form 90 ounces. To form 90 ounces means that the sum here is 90. And they're calling this the desired alloy. So let's go back. The desired alloy here. Desired alloy is actually 17.8%. So here, this is a 17.8% mixture. And let's read this. We don't know, in purple, how many ounces of 13%. We're going to let that be X, the quantity. And then that's going to be mixed with, let's again, mix with 29% alloy. Okay, and that's it. It's going to be mixed with just simply 29% alloy. We don't know the quantity there either. That's why we called it simply Y. Look at your equations now. We get the following. 13% of X plus 29% of Y is going to give us 17.8% of 90. That's times 90. Now, 17.8% of 90 we can compute. So that's 17.8%. And let's remember here how we do the computation. Whenever we compute, we have to move that decimal. So it's 0.178 times my 90. I get 16.02. 17.8%. So let's look at the equations here. My first equation is x plus y is 90. The second equation is 0.13x plus 0.29y is going to be 16.02. Move my decimal 2 spaces. Here's what you end up getting. 13x plus 29y will be 1602. First equation, second equation. Solve that second equation for x by translating your y. Okay, x is 90 minus y. 90 minus y here for x. Here we go. 13 times 90 minus y plus 29y is 1602. Now we're going to actually get rid of the parentheses, so we need to know what 13 times 90 actually is. And that's 1170. So we're going to get here 1170 minus 13y plus 29y is 1602. Or simply 1170, 29y, that's going to be plus 16y, is 1602. Subtract now your 1170 from both sides. I get 16y to be 1602 minus 1170, 432. Divide both sides by 16, we end up getting y equals 432 divided by your 16 is 27. So y is 27, meaning we're going to have 27 ounces here. And 90 minus 27 looks like it's going to be 63. 63 ounces for 13%, 27 ounces for 29%. And the question is, let's see, what's the question? How many ounces of 13%? So they just want to know this number, 63, because how many ounces of 13% is the question. That's 20. 22. Another mixture question, so let's be careful here. How many liters? So the quantity here is in liters. Percent alcohol. The amount here is percent. We're going to get a mixture. Okay. How many liters of 30% alcohol must be mixed with 60 liters of 80% to get a 50%? So to get is the mixture. The mixture is a 50% alcohol solution. Let's see what the first type is here. So let's go back. How many liters of 30% alcohol? We don't know. It's silent on the quantity, so that's X, but we know it's of type 1, which is 30% alcohol. It's going to be mixed with 60 liters, so the quantity here is 60. 60 liters, and it is actually an 80% solution. So you're mixing a 30% with an 80% to get a 50% solution. So if you don't know what X is, the sum we're going to call Y. That first equation is X plus 60 is Y. Now let's look at the percent here. This is simple now. 30% of X, and then we get 80% of 60. We're going to find out what that is. Your mixture better be 50% of that Y. So 80% of 60 is 0.8 times that 60, and you get 48. So this value here is simply 48. Second equation is 0.3x. I mean, let's write it as we can write it as 0.30. Okay, 0.30x plus 48 will be 0.50y. Well, maybe we should just get rid of the zeros, because that's kind of irrelevant, after a decimal, how many zeros you have at the end of the number. That's going to make our computation a little easier. I'll show you why. Instead of multiplying both sides by 100 and moving the decimal 2 places, we can multiply both sides by 10 to move the decimal only 1 place. Okay, so this will be moved 1 place, 1 place, 1 place. The second equation really is going to be 3x plus 480 is 5y. First equation and my second equation. We're going to plug in for y here. Okay, let's go back. Since I already have this solved for y is x plus 60, I'm going to replace this y with x plus 60. Here's what you end up getting. You end up getting 3x plus 480 is 5 times x plus 60, or 3x plus 480 is 5x plus my 300. You're now going to subtract 5x from both sides. 3x minus 5x is negative 2x plus your 480. That's going to be 300. Subtract my 480 from both sides. I get negative 2x will be negative 180. Divide both sides by negative 2. We get x is actually going to be 90. So the question is, how many liters of 30% solution? Well, 90 liters of 30% solution is your answer for number 22. Finally, number 24. Chemistry class has 3 liters of 4% silver iodide, and it must be mixed with a 10% solution to get a 6% solution. How many liters of the 10% should be used? Okay, so we got 3 liters of 4% silver, 3 liters of 4% silver iodide must be mixed with, they just say a 10% solution. They didn't say how much the quantity is. So again, quantity here is in liters, and this amount is in percent. So 3 liters is my quantity for the 4% solution. It must be mixed with a silent amount, call it x, of 10% solution, x liters. And they want to get they're telling us they want a 6% solution. So the mixture is going to be a 6% solution, and we don't know what the quantity is here, so we're going to call that y. If we don't know what x is, we don't know what y is. So 3 plus x here is your value y. The rest is we're going to get by multiplying. So notice 4% of 3, or 40%. Nope, 4%. Multiply these two. 4% of 3 times 10% of x should give us 6% of y. 4% of 3, now that's 0.04 times 3. Right? You always use the decimal representation, and that's going to be 0.12. So I want to point out that this is actually a value of 0.12. Here's your equation. 0.12 plus 10% x gives you 6% y. Replace the 10% and the 6%. 0.10, 0.06. So we're going to have to multiply both sides by 100 to move these two spaces again to get some nice whole numbers there. 12 plus 10x plus 6y. First equation, second equation. And in the second equation here for y, you're going to plug in a 3 plus an x. Let's see what we get here. 12 plus 10x. Oops, there's an equal there. It's not a plus. Equals 6 times 3 plus x. Or 12 plus 10x is 18 plus 6x. Do some algebra. Subtract 6x from both sides. 12 plus 4x is 18. You're going to subtract 12, and you get 4x is 6. Divide both sides by 4. And x will be 3/2 or 1.5 liters. So my value here is actually 1.5 liters, and it looks like that's what they're asking. How many liters of 10% solution? Right here. 1.5 liters of 10% solution. And we are done with these mixture questions.